Hello there, welcome to A-Level Physics and Mathematics. In this section, I will break down unit vector for you guys. In last section, we have seen about zero vector. As you know that if suppose you have a vector v, let's say if you have a vector v, and then the magnitude of v is equal to, supposed to be look like this, right? So is equal to 0, then this vector is called a zero vector. So like I said, in this section I will break down unit vector for you guys. So before that, could you please subscribe, share, and then like this video. So like I said, in this section I will describe for you guys a unit vector. Unit vector is a very basic concept in physics. So unit vector means, if let's say if you have a vector with a magnitude of 1, is called a unit vector. As you can see, we have a definition over here. So a unit vector means a vector is a vector, or a unit vector is a vector that has a magnitude or its length, or the length of a given vector should be 1, or exactly 1 is called a unit vector. I believe you understand about a unit vector. Just to remind you, a unit vector means a vector with a magnitude of, or exactly the magnitude of the unit vector is exactly 1. So such vector is called a unit vector. And then this vector is basically help us to understand, specify, or it will help you to specify a vector, the direction of the given vector. So it will help you to understand, primarily it will specify the direction of the given vector. So this is a basic definition of a unit vector, as well as what's the use of this unit vector. So mathematically we can represent this unit vector. Look like this. Suppose you have a vector u, like I said, let's say you have a vector u, then the magnitude of u is, if the magnitude of u is equal to, if the magnitude of u is equal to 1, then such a vector is called a unit vector. So mathematically we can represent a unit vector look like this. Okay, this is how to represent a unit vector of the given vector. So we can represent, there is a common notation, or we can represent in a different way. So we can use a different symbol, or different variable, or different letter to represent a unit vector, like a hat, and then I hat, k hat, j hat, which is for Cartesian coordinate system. Let's say if you have a x, y, z coordinate, you can represent this. This is x, and then this guy is y, and then this, let's say this is this is z coordinate. So let's say you have I, j, and k. Let's say this is a unit vector I, and then we call it, this guy is a unit vector j, as well as this guy is called a unit vector k. Okay, this guy is a unit vector k. So we can represent look like this. We can use to represent unit vector j, I, and then k. I, j, k. Those are how to represent a unit vector. And then we can use another letter or variable letter as well. Basically, we can use E1, E sub 1, E sub 2, E sub 3, and then extra. We can use this notation as well. Most of the time we can use this in a quantum mechanics. If you are familiar with that, we can use those later in a quantum mechanics. So maybe we will see in the future about how to represent, or how to use this E, or later this notation in a quantum mechanics. Anyway, that's another topic we'll see in the future, like I said. And then like I said, we can use ijk, and then for x, y, z coordinate. these are basically how you can notate, how you can represent the unit vector. And then we have the next one. I just wanted to show you as well how to find out the unit vector of a given vector. So suppose you have a vector v with 2 dimension as well as a 3 dimension. For 2 dimensional, let's say we have a v1 and then as well as a v2, and then for a 3 dimension we have let's say we have a v1, v2, and then v3. We can calculate magnitude of this vector quantity. Basically, I don't think so. It's a very complex stuff. So we can calculate magnitude of a given vector v by using this formula. So for this is for 2-dimensional quantity or 2-dimensional vector basically. So for 2D we can calculate magnitude using this formula, as well as if a vector has a 3D like x, y, z, or ij, or ij, k, we can calculate the magnitude of that given vector by using this formula or using this way. And then the magnitude of the unit vector. Okay, so this is basically, those are the magnitude of the vector. Okay, don't forget that the magnitude of this vector v is calculated by using we can calculate using this formula, as well as the magnitude of v is we can calculate using this formula as well. However, I just wanted to let you know, guys, the magnitude of unit vector is we can calculate this formula. Don't forget this guy. It's maybe you may be find in the exam or in exercise basically. So the magnitude of a unit vector is given by a given unit vector v is equal to the given vector upon a magnitude of a vector v. So which is how to calculate the unit the magnitude of a unit vector. So I think that's all about this unit vector. So next, what I just wanted to let you know is I just wanted to have a few or a couple of exercises for you guys to understand this unit vector. So let's proceed with an exercise. We have a couple of exercises, I think so. Let me see. Let's say one. What is find the unit vector of find a unit vector in the direction of let's say in the direction of v is equal to 3 and then 4. So to calculate units, the magnitude of the unit vector, to calculate a unit vector, what we can do is we can just follow first step as well as the second step. So what we need to do is we need to find out the magnitude. So as I said, we have a vector v. So to find out the magnitude, what we can do is the magnitude of v. Let's say this is a solution. So v, the magnitude of v is equal to square root of 3 square plus 4 square, right? 4 square. So which is equal to basically square root of 9 plus what is that? Is that 20? 16, right? So we can get that 24 5. So square root of 25, this is a perfect square. So we can get 5. That is a magnitude of this given vector. Basically, it's a two-dimensional vector. So now the question is, it says that find a unit vector, right? So now to find a unit vector, what we can do is unit vector v is equal to v upon, or a given vector upon what? The magnitude of what? The v, right? So we have v, or the unit vector is equal to v, right? So v is equal to 3, right? 3, 4, right? 3, 4 over what? The magnitude of v is equal to 5. So meaning that, which is equal to 3 over 5 upon, or is equal 3 upon 5, and then comma 4 over 5. This is a what? This is a magnitude of a vector v, a unit vector, right? This is a magnitude. This is a unit vector, right? This is a unit vector. This is just a unit vector. To find out the magnitude, you need to calculate. Just let me check something over here. So what we can do is, you can verify this by using this unit vector, right? You can verify this by using this unit vector. So we have a unit vector. So to check if is this a unit vector or not, what you can do is you can find the magnitude of this vector, right? This unit vector, okay? This is a unit vector. Then you can find out the magnitude of this unit vector to check or to verify is this a unit vector or not. So to just verify or to check, what you can do is this care. So v, or verify, you can say that the square root of what? Square root of 3, 5 square, right? Plus, what was that? 4, right? 4 upon 5 the whole square. Meaning that this is a 9 upon 25 square root of plus 16 upon 25, right? Which is equal to 25 upon 25. Basically square root of 25 upon 25, which is equal to square root of 1, meaning that is 1. So that means the given vector is a unit vector. So you can find out, or you can verify unit vector, if the given vector is a unit vector or not, using this way. So that is it for this example. I just wanted to add one more example for you guys. Let's say we have, I just wanted to add one more example for you guys. So next, let me clean this guy. So next example, it says that find is a second example. Find a unit vector, vector in the direction, and direction of, let's say, a vector A is equal to minus 2, 1, as well as I guess 2, right? So yeah, it is. So to find out the unit vector, like I said, you need to just follow those 2 steps. So what you can do is, first thing is first, you need to find out the magnitude of a given vector A. So the magnitude of a vector A, let me this guy, the magnitude of a vector A, the magnitude of vector A is equal to square root of, right? Square root of, let's say 2 square is minus 2 plus 1 square plus this guy is a 1 square, and then plus 2 square, right? 2 square. So which means square root of what? 4 square root of, I mean, yeah, 2 square means 4 plus 1 plus what? Plus 4, right? So which is equal to 4 plus 1 is 5, 5 plus 4 is 9, right? 9 square root of, meaning that we can get square root of 9. So square root of 9 means, right? Square root of, let me put this guy, square root of 9 is equal to 3, right? That is it. That is basically a unit vector of a given vector. So you can find out the magnitude of a vector A by yourself. I believe you will get one, but let me know if you will get any challenge on doing this. I mean, if you get any challenge, I will help you. Just let me know in the comment section. So this is basically a unit vector for a given vector A, right? So that is all about today's section. So like I said, let me know if you have any question or any query. I'm happy to reply for you guys. And then if this session or this class help you, could you please subscribe, share, and then like this session, and then we'll proceed with the next topic in the next class. That's all about today. Have a good day. Thank you.